Hi, so I've been doing a bit of bench reorganisation. I realised that my old BBC micro system had been sort of skulking in the corner. I probably hadn't switched it on for sort of at least 5 years, so I thought it was maybe time to shunt it out and make space for something else, but I thought it might be fun to just take a look at it. So this dates back to probably at some point in the 80s. There might be a date in there somewhere. We'll take a look. At that time I was in the habit of building sort of computers into racks just so I could get all my sort of peripherals and so on. I subsequently did that. This is my Acorn A540 ARM-based machine, which probably also hasn't been turned on for 5 years. That's probably needs moving out, but this was sort of the first sort of major one, which is BBC. It's a BBC B+, which is the version I added a bit of extra memory and did some clever stuff with shadow memory, so you got lots of program space without taking out the screen area. And as I turned this on and it all worked pretty much. The hard disk, that's an old Seagate ST225, which is not the original hard disk I had. And there's a lot of stuff I can't find, which so I think that disk sort of probably replaced the old one, but I only had stuff that I'd sort of copied off of floppies or something, but also it seems to have issues. I tried copying some stuff. I was sort of digging around on these floppies and just tried copying a few things, but it didn't seem to want to write, so there's something a bit weird happening there. But so there's one bit of software I found which might be quite interesting. So we've got two floppy drives, 3.5 and 5 1/4. I'm sure when I originally built this sort of had two 5 1/4s, but then later as I was doing stuff on the later ARM, the Archimedes range, I'd have got the 3.5 in there just to be able to swap files between them. Next to it, that's actually a little peripheral that I built for showing the current track number on disk drives. So as it accesses the disk, you see it actually shows the current track number using the step and using the sort of step and direction line, and shows you the current disk. There's also switches here to switch the drives between 40 and 80 track modes. These TX drives, this is an 80 track drive, but some early BBCs use 40, so there's a switch you could, I think there's a link or something on the drive you could flip to turn it into 40 track mode where it double stepped. I think this is a second user port. We've got a built-in EEPROM programmer. The dip switches, those are on a RAM board. Basically the BBC Micro had what was known as sideways ROMs, where you had a 16K area of memory which was used for applications like BASIC, but that was paged, and you could have up to 16 ROMs in there and the operating system would just handle all that for you. So it could either be a language ROM that you would just go into and stay into, like BASIC or a word processor or other applications, or it could also have utilities, so you can type command line utilities. It would actually search through all the ROMs for the commands, so you could basically extend the operating system by adding these commands. Of course, this was, the entire thing had 32K of ROM, half of which was the operating system, half was BASIC, and then these other ROMs provided functions like, for example, disk operating system, networking, various utilities and so on. And the various connectors down the bottom, we've got the keyboard, that DIN, that's Econet, which is the networking system that they did, which is very popular in schools. It was based on like a synchronous RS485 type thing, which ran from memory up to something like a couple of hundred kbits, which worked quite well for networking machines, and you could have like a central file server and a print server. Next to that, that's an analog port that was used for joysticks and so on. I can't actually remember what's on the end of that switch. We'll have to have a look and find it. Actually, no, I'm thinking about it. One of the products I did at that time was a print buffer. Because obviously this thing didn't have a great deal of memory, so if you wanted to do a large print job, it would just hold the machine, it would just sit there while it's printing. So I think that might actually be one of my print buffer boards in there, and these are probably the controls accessing it. That's the printer port. That, I suspect, is probably power for something. I'm not really sure what. That's a user port. We've got, I think that was the cassette, RS232 or RS423 or 432. It's like 5-volt version of RS232, I think. That would be digital RGB for the monitor. Then we've got composite, which I can't remember whether I'd got colour on that, because I'm putting it through, I haven't got a composite monitor, I'm just putting it through just a converter to a VGA, and I'm not getting any colour. There's a couple of switches here. Now this has got an internal 6502 second processor. Again, this is something that Acorn came out with, where you add the second processor, and then the main BBC just acts as an I/O and file system. So all your code ran on the second processor and just squirted stuff out of the, there's a chip called a tube, which is like a bidirectional FIFO chip that it could just send all the I/O and video stuff through, which is quite a nice way of just running bigger programs. It was also faster. That's the tube connector. I can't remember exactly what's going on with these switches. One of them definitely turns the 6502 second processor on and off. I can't remember if I ever had another second processor like a Z80 or something in there. Again, there might be some remnants of that in there, so I'll have to open it up and take a look. And that's the 1 MHz bus connector, and that's connected to the hard disk. So that's just like a 6502 bus running at 1 MHz that was used for various peripherals, in particular the hard disk. And sort of quite surprising, this thing just started up first time. The hard disk is mostly working. So there's quite a lot of stuff that I can't actually find on here, so we can actually run something. Okay, so yeah, it's got some pictures. One of the things I built on here was a video digitizer, so these are just some, I think these are probably some stuff that I did using that. Again, loading some fairly crusty low-res images. Now, one thing I did find was the first bit of PCB software I ever wrote. So this is about 500 lines of BBC Basic, which would allow you to do very basic PCB layout. So you could sort of put a few pads in. I think this is entirely keyboard driven, so you could sort of create a few pads. Obviously no symbols or nets or anything, it was just very much a specialist graphics thing. So is it track mode? Yes, I can go start a track. So it's extremely, oops, I could delete that. So it was vector based but produced a bitmap and printed a bitmap. There's a help page, and the help page, it actually saves a screen image before putting it up because it takes so long to redraw. So it's just got some very basic editing functionality. So I can also go into edit mode. I can just, to edit anything, you literally got to just step forwards and back through the database, and all you can do is just go to a thing and delete it, and then you have to sort of redraw it. But I did do one fairly complex PCB on this, and this takes quite a long time to redraw. This is actually the RAM board that's in this rack. So I think this got drawn out, and I think this then got printed on, it would probably have been a matrix printer onto tracing paper to then photo etch the PCB. But say this PCB is actually inside here, so I'll take a look at that. But as you can see, it was a little bit on the slow side. It's using sort of dotted, I think there's 3 different line widths, and there's like dotted and solid lines just to indicate those different line widths. Because this is only a 640 by 256 display, no zoom or anything, it's very much fixed resolution. So yeah, I hate to think how long that actually took to draw. Turn the grid on and off so I can edit it, but the editing is really painful. So you can see it's, if you look down the bottom right hand side, it's blinking some pads, so I can sort of delete those pads. I might be able to undelete. Can I undelete them? No, I can't. And then when I exit editing mode, it's then chugs away compacting the database. So it's it was okay for very basic boards, but I think fairly soon after this I got the first ARM machines and wrote some PCB software on that was a lot more usable. But this sort of did just about sort of work. And the EEPROM program, that's something I designed myself. EEPROM programmers were very popular things to build in those days. You could buy commercial ones, but they were very expensive. But obviously, because the you know, a lot of the software was done in ROMs in these things, then yeah, EEPROM program was very handy, either for doing your own stuff or copying other people's stuff. So I wrote this program. This is all in 6502 assembler with sort of fairly comprehensive sort of functionality, with sort of full editing and all sorts of stuff. I think it would even, yeah, there's an upload facility for an external programmer. You can download copies of the ROMs that are built into the system, so I can say download a copy of the basic and then sort of look at that. So this is very much targeted. This was never commercialised. I think 1 or 2 friends built 1 or 2 of them, but I don't think there was ever more than 2 or 3 of these in existence. But the software was quite a lot nicer than it really needed to be, but then again I didn't really have anything better to do in those days. So this is all into a standard 19-inch rack. So basically I built this case, this is built out of aluminium angle, a sort of frame out of aluminium angle. There's a standard rack unit goes, and then the rest was just built on a tray underneath. This doesn't use a backplane or anything, it's just each peripheral is just specific. It's got its backplane connector just wired to wherever it needs to go to. So this is the ROM board again. Yeah, boards to take multiple ROMs were a very common add-on to BBC Micros because the standard machine would only take 4. So a lot of people added for boards of varying degrees of mechanical and electrical integrity. There were quite a few commercial products. Some were quite good, some were sort of pretty terrible. So there's just various ROMs in here. There's sort of different versions of BASIC, word processor, my EEPROM programmer software, network, BASIC editor, yeah, various other odds and ends. Now the construction on this is, look at that, that's done with a system called Roadrunner, where it's just like a wiring pen. Actually, I've probably still got it. Where is it? Yeah, so it was this system. So basically you had a sort of pen with a spool of wire. So you sort of the wire comes out of this sort of thin little thing. You then stick these combs down on the PCB, so you could sort of guide the wire in. See, they're slightly tapered, so you'd sort of start from a pin, guide the wire in, run it along, then run it back out again. So as long as you keep track of what's where, and it used a fairly low temperature enamel, so you could solder it and it would burn through the insulation. So from a sort of square pad board, it was sort of fairly effective way of doing quite dense prototypes. Again, this is sort of a bit extreme, but obviously it does allow, yeah, it is very compact. There's all, yeah, that board is a very well used space. There's not really any wasted space on that. Obviously it's a nightmare to debug and fault find on, but it's quite an interesting construction technique. And next one, this is a RAM board. So in addition to these ROMs, another popular mod was to just put some RAM in there, so you could just load a file from disk instead of burning it into a ROM. So this is my own RAM board, and so this is the board that we saw on the PCB software, so you can actually see it's fairly sure this is printed on a dot matrix printer in like the highest resolution you could get out of it in multiple passes. Very good to date, November 1984. So yeah, that was sort of home etched PCB. I think that was possibly for a battery backup. I can see some bits of corrosion on there, so there's probably one of those NiCad batteries in that hole originally, and there's various sort of little interesting little germanium diode, which is presumably for the power switching. Some 74LS 6264 RAM chips, so it's 32K altogether, 2 banks of 16. I suspect these switches were probably to select which of the 16 banks it appeared in. I think that was probably a buffer that turned out to maybe cause problems, had to bypass it. And there's the EEPROM programmer. So there's all just sort of hand wired on prototypes. So there's a 6522 I/O chip. There's some high voltage generation circuitry. I think this could generate 1 or 2 different voltages on it. There's a few presets, so each of these will probably to set one of the voltages. And there's a switch. These are for like 24 and 28 pin EEPROMs, and there are a few different permutations of the pin out. So this switch just selected the various chip select and programming voltage for the 4 different types of chip. There's a few odd bits of just TTL in there, but nothing too exciting. But it was quite a good design. It worked quite reliably, and so a few other people built them and used them, but I didn't really have the connections to take anything commercial, and also it was towards the end of the life of the BBC Micro. I never really did anything commercial on the BBC because sort of the ARM-based systems came along, and I did quite a lot of peripherals for that. And I think this is just another. Oh yeah, it's not even there, but this was for 6522, just an additional user port. I can't remember whether I made that for anything specific. It might have been for like a trackball or some other peripheral. I really don't remember. And this is the disk track indicator. It's just some of these CD40110. So these have been sort of counter display decoder chips, and just some very simple TTL logic to take the step and direction. So I think these are just bidirectional counters. So the direction line just goes off the direction line, and then the step just counts them up and down. And there's probably a reset from the track 0 detection. I seem to remember that was quite useful when hacking disk protection systems, so you could see what track it was looking for. And then there's a power supply. So the original BBC power supply is here for the main machine, but this was just running all these extra peripherals and disks. So there's a Looks like a fairly crusty linear power supply, big transformer in there. Nice sort of backplane connect. Probably about the last thing I ever used this for was for programming serial E-squared proms. This is actually a programmer box that I did as a sort of very small run product for a sort of niche market for programming EEPROMs in things like car stereos and early analog mobile phones. So this had pinouts for a few different E-squared proms, but it also, this is sort of fully potted, it also had some security features, because it was one of those markets where everyone would just copy something as soon as they got hold of it. So the software was actually quite sophisticated. It had like different modules that were encrypted with encryption keys stored in here, so that someone could buy a system. I could then sell them upgrades by just giving them a code to actually unlock certain functionality for different chips. Didn't sell many of those, but they were sold at quite a high profit, so it was worthwhile doing. But I still use that occasionally for odd little E-squared prod jobs up to maybe a good few years ago. Actually, now I'm thinking about it, I've got a feeling when I first built this, it had like something like an issue 3 or 4 BBC Micro board in it, but at some point it got changed to a BBC Plus board. So I think there's some features that are on the panel that aren't actually connected to anything inside. Fairly sure that the print buffer isn't actually in here anymore, but I did actually find the board. So this is the first product I ever got paid to design, or I designed it and then got sold it to Watford Electronics at the time. And so what this did was it pretended to be a fast printer, so that you in those days you type print on your word processor and it will send stuff to the printer, and you just have to sit and wait for the printer to finish before you could do anything else. So this used this Rockwell 6511Q, which was basically a 6502 with some built-in peripherals. So there's a little bit of RAM built in, some I/O ports. So this was designed, this was basically a very early microcontroller. It's in this sort of funky quad inline package, but obviously because it's 6502 based, and so was the BBC, you could actually use the BBC's built-in assembler to cross-assemble code for this. And this actually used a few fairly clever tricks in that this will take up to 256k of RAM, which is obviously quite a lot more than there was actually in the computer. These are 256k by 1 DRAMs, and these are actually, the access for these are actually bit bash. So it used the I/O ports to set up the address and the data lines, and actually there's just 2 chips here, I think were to just generate the actual RAS and CAS waveforms. But you could actually fit, I can't remember which, but I think you could fit either 1, 2, 4 or 8 chips, and it would detect how many chips were fitted and then shuffle the data around, so you could actually have different versions using the same board. Although it was only one bit wide, because it was accessing everything through I/O, it could just handle that. And so there was this switch that had different modes. So there was like a straight through buffer mode, and it would do stuff like hex dump mode. So it was handy for like debugging problems with graphics printers. You could actually make it do hex dumps and various other things. But yeah, it's a bit of nostalgia. It was 1986. I don't think I did the final board. I think I did a rough board layout in a CAD just a general graphics program, and they had their PCB guy actually, because I didn't have any way of generating sort of actual artwork quality boards at the time. So I just think I did most of the design either on paper. I can't remember, I might have actually done it on paper or something, but they then actually did the production version of it. But yeah, it's a sort of 30-year-old bit of memory lane there. And the other thing you could do with this, I think you could actually download a whole document into it and then just print to get multiple copies. Again, we're talking back in the days of like dot matrix and daisy wheel printers. So if you wanted 2 copies of something, it would just take twice as long. So I think you could actually just, as long as it would fit in the memory, you could download the whole thing, press a button, and you just do a repeat copy. So this is a homemade case, and you could buy rack cabinets, but that was just crazily expensive, and this dates back to when I had very little money to spend on stuff. So this is just made out of aluminium angle screwed together with these nice 4BA slotted screws. And this sheet is just like a aluminium with like a plastic surface laminated onto it. So just looking at, so I have memories of there being more stuff in here, but so I think possibly when I replaced the board with a B+, I think some stuff maybe got taken out. Perhaps it was getting a bit too cramped and hot. But so it's a standard BBC Plus board, and you see the back plane, it's all just variable and wires. So for example, the ROM board goes down these wires, down into a header, into one of the ROM sockets down there on the main board. Back connectors, it just plugs into the back connectors. It looks like I turned that analog port around 90 degrees, and there's just stuff plugged in running to the front panel. And there's some interesting IDC ribbon cable hacking on the disk drive track number indicator board. I don't think there's actually that many mods on the main board, because by the time they got to the B+, they'd sorted out most of the issues, so it was actually a very solid board. It didn't need too much adding to it to make it into quite a nice board. It's probably one of the cleanest ones they did. Well, looking at the front, so most of these are just connectors going off somewhere, but I found no idea what this is. I think it's a little programmable logic chip which seems to be connected to the 1 MHz bus. So I think, because my programmer worked on the 1 MHz bus, and I think it's also being used for the user port, so I can only assume that this might be some sort of address decoding or something to split the addressing between the internal bus and the external hard disk port, but I have no memory whatsoever of what that's actually doing. And in here we've got the 6502-second processor. Let's see if we can actually get that out and take a look. This is the connector for the what they call the tube connector for the second processor, and so it looks like it's going up to here but also to the front panel. And I think there's some of this switching here is just controlling some of the select lines, so you could select either the internal one or an external one. And I'm fairly sure at one point I did have, I think it was possibly a Z80 one in here as well. So there was like one switch that controlled like either no second processor, Z806502, and I think maybe the other switch perhaps enabled the external. So it looks like there's some pins going to the external tube port, but so memory is very hazy as to what this actually got used for. Yeah, and this is the second processor board, which again, it's got a few mods. I think I had another processor board attached to this. So it was either a Z80 or it might have been, because I think on the BBC Master they had a 8086 or some similar PC type plugin, and it could be that was for that. Obviously it came out, maybe it never worked properly or something, I don't remember. There's a few other mods, like the voltage regulator has been taken out because it's been running from an external power supply. But say basically this is pretty much a 6502, just a very minimal bit of code just to talk to the outside world. So pretty much all the operating system call. Yeah, BBC was unusual in its day of actually having a proper operating system with calls for all the I/O functionality. They completely split out the basic and the operating system, and had like a standard set of calls, so that by just intercepting all those, they could divert it through. This is what they called the tube ULA. So the ULA was like an uncommitted logic array, which is like a sort of gate array that was customizable. And so this implemented some FIFO buffers, sort of buffers out for the video mostly, and also some for the file system, so they could get reasonable efficiency. So they could like throw a few bytes out without handshaking. So this is all done in software. So there's just like 64K of RAM, and just the rest is just LSTTL, mostly to do with making the RAM work. But these were very much sort of hotly anticipated. They had a lot of problems with this tube ULA apparently, with sort of stability issues, but once they got that working, this is a very nice upgrade in that you could make the thing run faster with lots more memory. I can't remember what these cost, but it was I do remember very eagerly being on the waiting list for getting these, and being very excited when they came out. And looking at the fact the crystal was in a socket, I suspect there was some overclocking experiments going on. So the nice thing, because it was totally decoupled from the rest of the system, you're no longer limited to certain frequencies to deal with to match like the video speed or anything else. So I can't remember whether this is actually being overclocked here, but I'm pretty sure I would have had a good play to see how fast I could make the thing run. I don't remember whether you could actually achieve much, but that would certainly be why that crystal is in a socket. Now this was, I think, a fairly late hard disk edition. When the BBC hard disk came out originally, it was a sort of fairly big box, very expensive. It had one of these boards in it. This is sort of interfaces the 1 MHz bus to SCSI, and they then had an Adaptec ACB 4000 board, which then interfaced SCSI to ST506, which was the standard hard disk interface of the day, which is very similar to the floppy interface. It's just a basic like step and direction motor interface and raw data. So there was a lot on that board. Where I was working at the time, we actually had quite a few sort of BBC hard disks as network servers. So these was like crazy expensive things. So for my first hard disk, I actually took one of those hard disks apart. I don't think I actually told anyone I did this at the time, and took this board out over a weekend and actually traced the entire circuitry out of this board and basically made my own one, which I think I may have actually used that Roadrunner system to make that as well. Then interface that, I think I bought an Adaptec board and an old Mitsubishi 20 megabyte hard disk, which was something like about £200 back then, which was sort of 20 megabyte drive, which that kept going for a while. But I suspect what happened is that when the place I was working at sort of ditched a lot of their BBC Micro gear, I think I probably rescued this controller board and stuck it in with a SCSI disk just to make a more compact, more reliable system. I've got a feeling that this would there were certain SCSI disks that the BBC disk system would actually control directly. I can't remember if there was any minor tweaks or hacks needed, but I seem to remember there were only certain disks. I think it may have been to do with sector sizing, because the BBC used 256 byte sectors, whereas a lot of hard disks would only run 512 byte sectors. So I think one of the reasons for using the Seagate 225, it was one of the few disks that you could actually format as 256 sectors. I think one job I did actually quite late in the day on the old BBC Master Series was actually write basically a hacked version of their disk filing system to actually run 512 sector drives by doing sort of reads and writes into a RAM buffer to make the system think it was using a 256 byte sector drive, but it's actually 512. But that was, say, back in the dim and distant foggy memories. I wish I kept that that interface board actually, because again that was quite an over the top bit of wiring. But so it's quite interesting. This is still working after, I'm not sure how old this drive is, but and there's an O2 on that there, so that's just 2002. Well, I'm not sure. No, that sounds too recent actually. Maybe a bit. There's also an X8836, so perhaps it's 1988. But interesting is to say the whole system's not really been running for probably at least 5 years, and it just fired up straight away, no problem, which is quite nice. But this is now, I think this is going to be resigned to offline storage somewhere. I can't imagine why I would ever want to actually get anything off of this, but it's a bit of history that I probably want to hang on to. I think someone actually does like an SD card interface now for BBC, so I might sort of get hold of one of those and just if only just to copy all the stuff that I wrote onto it, just so I've actually got some record of it. I think there's also people who've done like BBC micros in FPGAs, which might be quite amusing to have a play with at some point. So if I've got some of my own software to run on them, it might be quite fun to try. But yeah, I thought I'd just, if only to remind myself what's inside this thing, I thought it might be interesting to take it apart. But so this is now being relegated to offline storage to make room for more shiny bits of test gear and so on.